Welcome to our this session on DeviceNet protocol. Till now, we have covered RS-232, RS-485, 20 mA current loop, Modbus and HART protocol. If you have not gone through those sessions, do watch the same for understanding different industrial communication protocols for industrial automation. In our current session, we are going to study about DeviceNet protocol. Before I start, I request you to share your valuable feedback about this session in the comment section. For a session on any topic of your choice, you can let me know in the comment section. Now, without any further delay, let's start. DeviceNet is an industrial communication protocol which was originally developed by Allen Bradley. Now, Allen Bradley is owned by Rockwell Automation. DeviceNet was designed to interconnect lower level devices like sensors and actuators with higher level devices like controllers. It is a protocol based on controller area network and was initially used in automobile industry. Controller area network CAN bus was designed by Messrs. Bosch as a robust network to allow microcontrollers and devices to communicate with each other's application without a host computer. CAN allows variable multi-byte message format which is used in DeviceNet 2, which enables DeviceNet in passing more information in comparison to fixed length bit type message system. DeviceNet is an open standard. Open DeviceNet Vendor Association (ODVA) has been formed to issue DeviceNet specifications. ODVA offers technical assistance to manufacturers who wish to implement DeviceNet in their products. DeviceNet can support up to 64 nodes. It supports bus topology, trunk line and drop line. DeviceNet supports data rate of 125, 250 and 500 kilobaud. In this protocol too, data rate can be traded off with distance or length of the network. DeviceNet implements only 3 layers of the OSI model, that is first, second and seventh, which are physical, data link and application layers. DeviceNet network supports bus topology. Main line, which is the bus or trunk line, is the backbone of the DeviceNet network. It must be terminated by a 120 ohm 1/4 watt resistor at both the ends. A drop line is a line drawn out from the trunk line and is used to connect nodes in the network. Drop lines could be 6 meters long. A node could be connected directly in the trunk line or in a drop line through a tap. Branching to multiple nodes is allowed only on the drop lines. Trunk line supports tap and multi-port taps only, which are used for connecting drop lines to the associated nodes. 3 types of cables are used in DeviceNet network, that is flat cable, thick cable and thin cable. Flat and thick cable are strong and resilient, so basically used for long distance. Thin cable is used in drop lines for connecting nodes to the trunk line. DeviceNet network length. This is the chart from which we can see the total length of the network will vary with 2 things: the type of cable used and the desired data rate. For thick wire, trunk will support 500 kilobaud up to 100 meter only, while 500 meter for a data rate of 125 kilobaud. For thin wire, trunk will support a trunk length of 100 meter only, irrespective of the data rate. For flat wire, trunk will support 500 kilobaud up to 75 meter only, while 420 meter for a data rate of 125 kilobaud. Number of nodes for all three types of wire and all data rate is fixed at 64. Drop line permissible, maximum length is 6 meter or 20 feet. Permissible cumulative drop, which is the addition of all the drop lines, varies with data rate. At data rate of 500 kilobaud, cumulative drop could be up to 128 feet, and at 250 kilobaud it could be 256 feet, and at 125 kilobaud it could be 512 feet. With this, I end the first part of DeviceNet protocol. In my second part, I will explain how does DeviceNet works. Till then, stay tuned, keep watching and learning. If you want to have a session on any particular topic, let me know in the comment section. Bye for now, we'll post my next video very soon.